Okay, hello again, ladies and gentlemen. All right, so I looked at a bunch of the proofs that came in from the homework, and I got to say, I was pretty impressed with a lot of them. Okay, usually students have a tough time catching on to this, but a lot of you seem to do a really nice job. Okay, that said, there were still a lot of things that need to be addressed. Okay, so hopefully everybody is watching this, and I'm going to go through all of these proofs and talk about some tips along the way that you're going to need going forward, for the next homeworks. Okay, so pay close attention. All right, so this is number one. Okay, I had given you the tip right before you did this that you have to pay attention to the givens. Okay, in this case, um, I'm given AB is congruent to BC, so I'm gonna mark that AB is congruent to BC. Okay, now this says BD bisects angle ABD. That's all it says. It does not say it's a perpendicular bisector of anything. Okay, a lot of you threw in the term perpendicular bisector probably just as a force of habit. You got to be careful. Nothing says this is perpendicular to anything. All it's saying is that BD is bisecting angle ABC. That means that this angle is congruent to that angle. That's all it says. Okay? So be careful about throwing in the word perpendicular bisector when you really only mean an angle bisector. Okay, this is an angle bisector. Okay, it doesn't say anything about bisecting segment AC. Okay, a lot of you had that marked and said it in your proof. Doesn't say that. Okay, so be careful about that. Okay, and then the third piece, of course, is the reflexive side. Okay, that silly reflexive postulate's going to come in very handy in a lot of these proofs. Okay, so now I've got my side angle side marked. All right, so I'm just going to write it. So start off my text box. Okay, um, I'm going to say 1. I'm going to say AB is congruent to BC. Okay, reason 1 given. Okay, now another thing people did was they skipped inserting givens into the proof. If you are going to say something based on one of the given has to be stated in the proof first. In other words, getting back to my courtroom analogy, if I came in here right now with what I have here and I said, oh, angle ABD is congruent to angle CBD. Oh, objection. What makes you say that? How can you say that? You haven't established that BD is a bisector of ABC yet. You need to say that first. Okay, so your second statement in this case needs to be 2. Okay, now that this will be that second given. BD bisects angle ABC. Okay, you must have the given in there in order to base any later statement on that given. Okay, so it has to be in there. You have to state it. Okay, so 2, that's also a given. Okay, now we can say, based on that, we can now say angle ABD is congruent to angle CBD. Okay. Angle ABD is congruent to angle CBD. Okay. Now I can put in here, I can put in 3. That is by definition of angle bisector. Okay. This given says that BD bisects the angle. That's it. Doesn't say anything about bisecting AC. All right. So then that's that. All right, so we move on. The next step is going to be step 4, which is BD is congruent to itself. BD is congruent to BD. Okay, and then I'm going to put in 4 here. Okay, 4. This is the reflexive postulate. Okay, and now I've pretty much proven everything that I need to prove here. Okay, so 5, I'm going to say triangle ABD is congruent to triangle CDB. Okay, I'm going to write this as the way it is in the proof statement. I'm going to call it ADB. Okay, and our reason will be 5 SAS is congruent to SAS. Okay, so that's that one. Okay, so just a quick note about what I was talking about. Okay, we have 3 words. We have perpendicular, which means that 2 lines meet at a right angle. If it just says perpendicular, all you've got is a right angle, or possibly 2 right angles. If they intersect and form a T, it's 2 right angles. Okay. Then you've got perpendicular. Then you've got, let's say, bisector. Okay, the word bisector. Okay, the word bisector could be referring to either a segment or an angle. In this case, it was only referring to the angle which was being bisected. Okay, there might be another, in example 3, the 2 segments bisect each other. I'll talk about it again when we get there. Okay, but then that's a bisector. 2 completely different words, perpendicular and bisector, mean 2 completely different things. Okay, and then we've got perpendicular bisector, which is another third term with its own meaning. Sure, it's a combination of the 2, but it has a specific meaning. And if it doesn't specifically say it's a perpendicular bisector, you can't assume that it is. Okay, perpendicular bisector is going to mean that the 2 segments are perpendicular, and that perpendicular bisector actually splits the other segment in half. Okay, so that is a very specific definition. Perpendicular does not necessarily mean perpendicular bisector. Bisector doesn't necessarily mean perpendicular bisector. Okay, only perpendicular bisector specifically means perpendicular bisector. So be careful about mixing and matching those terms because they're all different. Okay, I hope that's clear. Okay, so here's number 2. All right, so I'm going to mark the diagram based on what I'm given. I'm going to ignore those little dashes. There's supposed to be above the segments. It's supposed to say segment DG and segment EF, but they got shifted to the left a little bit. So I'm going to just ignore those. Okay, DG is congruent to EF. Okay, A is the midpoint of GF. Okay, so A is the midpoint of GF. That tells me that this segment will be the same as that segment. Okay, and now DG is perpendicular to GF. Okay, there's the word perpendicular, not bisecting anything. It's just perpendicular. Okay, EF is perpendicular to GF. So those are perpendicular, meaning they form right angles. Okay, so now I've got everything I need for side angle side. Okay, so the first statement, always got to start off with a given. Okay, so I'm going to start off with the first one. DG, I'm just going to write CONG, congruent to EF. Okay, that is given. I got to number them. Okay, given. Okay, and then that's my first side. Okay, so my next statement will be the next given, 2. All right, A is the midpoint of GF. Okay, see how I'm abbreviating? That is perfectly okay for you to abbreviate if you want to. Okay, given 2. This is also given. Okay, so what do I get from that? Okay, well, I got from that GA is congruent to FA. All right, so I'm going to put that in. GA is congruent to FA. Okay, and that would be, the reason would be, whoops, 3. That is by definition of midpoint. Okay. All right. Now, this brings me to combining statements. Okay, it is okay to combine statements in the following situation. Okay, if the two statements basically say the same thing and have the same reason, you can combine them. So the next two givens are basically saying the same thing, that a segment is perpendicular to another segment. So I can combine them into one numbered statement and only write the reason once. Okay, so what I'm going to do is for 4, I'm going to say that DG is perpendicular to, I'll just say perp, to GF. And then I'm also going to say EF perp to GF. Okay, so I'm combining them into one numbered statement because they're basically saying the same thing. Segments are perpendicular to each other. And I can combine them because they have the same reason. They're both given. Okay, so feel free to combine statements in that specific situation. Okay. Now, something some of you left out, once you say that, well, what does that tell me? Well, now, in order for me to use that the two angles are congruent to each other, I need to say that. Okay, I need the given to support the statement, and then I actually have to make the statement. So I'm going to say 5, angle G is congruent to angle F. Okay, now since these angles are the only angles at those vertices, I can use a single letter. So that's another rule of thumb. The only angle there, I can call it by a single letter. So I can call angle G and F by a single letter. I can call angle D and angle E by a single letter. But those angles at A, like EAF or DAG, have to use 3 letters because there is more than one angle there. Okay, so for number 4, now I'll put in 5. The reason is, okay, perpendicular segments form congruent right angles. Okay, that would be my reason for that. Okay, now I've got everything I need. Got my sides, I've got my angle, so I can now say 6 triangle DGA is congruent to triangle EFA. Okay, I spelled triangle wrong. See if this will fix it for me. It's not going to fix it for me. Okay, that. And my reason, of course, is side angle side again. Okay, so 6. SAS congruent to SAS. Okay, so number 3. Only one given here. QT and PS bisect each other. Okay, again, not perpendicular bisector. They're just bisectors. They bisect each other, so that's going to mean that QR is congruent to TR and PR is congruent to SR. Okay, so now just with that one given, we've got the 2 pairs of sides congruent to each other. Okay, and anytime we've got intersecting lines, we've got vertical angles. Okay, again, intersecting lines, we don't have to be told that. That's the one thing about the appearance of a diagram that we can assume from that diagram. Okay, we don't have to be told that the 2 lines intersect. Okay, so we'll state the given. QT and PS bisect each other. Okay. Given. Okay. Then from that, we can combine 2 statements now because we're basically saying the same thing in both of them, and they will have the same reason. So I'm going to say QR is congruent to TR, and I'm also going to say that PR is congruent to SR. and to, and I can given to. Okay, this is by definition of segment bisector. Okay. Now, 3, we've got the vertical angles. We've got angle QRP. Again, I can't say angle R is congruent to angle R because I got more than one angle there. So I have to say angle QRP is congruent to angle TRS. Okay. And this is how we would need to state that reason. We need to say intersecting lines form congruent vertical angles. Okay, spell vertical wrong. Vertical right. Vertical. Okay, intersecting lines form congruent vertical angles. That's how you should word that reason. Okay, because it's telling us what do we got? We got congruent angles. Why? Because they're vertical. And where do they come from? They're from the intersecting lines. So that reason is a completely worded reason for why we can state that. All right, and now nice easy proof, just a couple of steps here. So number 4, we're basically done. Triangle PQR is congruent to triangle STR. Okay. And our reason is going to be for SAS to SAS. Okay, and that's it. All right, so just keep all the things that I told you in mind about making sure you state the givens before you state the information from those givens, and you must make those statements as well. Okay, so every statement has to be laid out, again, just like a court case. If you say something before you can prove it, I object. I object. There's no way that you can say that those two segments are congruent to each other because you didn't say they bisected each other yet. So that statement must be in the proof first before you can use the before you can use the information in another statement. Okay, hopefully that's clear. All right, guys. So see you next time. Good luck on the next lesson.